Hello, welcome back. In this video tutorial, we're going to be looking at physics homework number 5. PH number 5 also deals with graphical analysis. Now, specifically, it focuses on a velocity versus time graph. Now, there's a couple things to note about velocity versus time graphs. Number 1, the slope of a velocity versus time graph is acceleration. The area under a velocity versus time graph is displacement. So we're going to be focusing on these two main concepts as we go through. Now, of course, the third thing you can do is simply read off the graph. I mean, you can tell what the velocity is at any moment by just simply reading off the graph, okay? So let's begin. The first thing I'm going to do as I look at a graph is I'm going to try and figure out what the motion is, like what's going on with this thing, and then I'll actually look at the questions to see some detail. So I'm seeing that this object, whatever this object is, so it's an automobile, okay? So the automobile starts the clock at 0 seconds. The car is going 20 meters per second. Now at 10 seconds, the car is going 0. So what happened here? The car slowed down. Okay, so we're slowing. Now, since the velocity is on the positive side here, it's slowed down going forward. Okay, now let's put those together. When you're slowing down, you're going with a negative change in velocity. Going forward is a positive direction. Put those two together and we're looking at negative constant acceleration for the first 10 seconds. Okay, now from 10 to 30 seconds, that little section right there. Right there. Sorry, 10 to 25 seconds, I misspoke. The car is at rest, right? So velocity equals 0 right there. Okay, so the car stopped. So the car is slowed down, car stopped for 15 seconds. Now the car appears to be going in the negative direction, right? Because now the car is at negative 15 meters per second. So car could be backing up, or maybe the car is going to the left, right? I don't think the car is going downward. That would be pretty dangerous for a car. But the car is most likely going to the left on whatever this, coordinate direction frame of reference is, or most likely just going backwards, okay? But the car is gaining velocity from 0 to 15. So the car, I'm just going to use forward and backward right now. So the car is speeding, which is a positive change in velocity, going backward, which is negative. So this is also negative constant acceleration. For those 15 seconds there. Okay, so now for the next 15 seconds, from 40 to 55, we have this. Okay, now you could look at it in two ways. So I'm going to actually split that up into this section here. So here the car is going 15 and then is back down to 0. So what did the car do? The car slowed down. Slowed down, but you're in the negative direction. So the car slowed down going backwards. So both those negatives mean that this little section here is positive constant acceleration. Okay, the car has also stopped right there. So V equals 0 right at 45 seconds. Okay, and now here for this section, we are speeding up from 0 to 30. There we go. We're speeding up. Okay, and you're going in the positive direction. So you're going forward. So both of those are also indication of positive constant acceleration. So it's positive constant acceleration the whole way. And the easiest way, this is kind of like a cheat code for the problem, the easiest way to remember this is positive slope, right? Positive constant acceleration, negative slope, negative constant acceleration. It doesn't matter what side of the t-axis you're on, okay? Because you're going to get that same result. If you look here at the top, for those 15 seconds, 55 to 70 seconds, we are looking at, again, v equals 0. No, not v equals 0, sorry. V is constant. So constant velocity, positive constant velocity specifically, at 30 meters per second. Okay, then we have the speed is going from 30 meters per second back down to 0. Okay, so for there, we are slowing down, okay, but we're going forward. So that combination, right, is going to be looking like negative constant acceleration until we stop right here. Okay, let's take a look at the problem. Number 1. What is the velocity of this car when t is equal to 35 meters or 35 seconds? So number 1 is just a straight read off the graph. Okay, find 35, look up the graph, and find the velocity. Okay, so if I can see here, 35 would be right there. That's where it is on the graph. There's the velocity right there. Okay, now please note that for the next 3, when we are finding the acceleration of this car, we are taking the slope, okay? Slope at that time. For 5 through 7, we are finding the area under during those time intervals. That's going to give us the displacements, okay? Now the total displacement, we got to add up our areas, all right? So that ultimately is how we're going to go ahead and work this. Any extra room we need to write, we'll write down below in the margins, or if you need to use a separate piece of paper, go ahead and use a separate piece of paper. All right, so let's figure this out. What is the rate of acceleration? It is the acceleration of the car at t equals 20 seconds. So what we do is we go to 20 seconds on the graph, we find that line segment, and we find the slope of it. Okay, now I'm going to erase a lot of these highlighted areas. Don't need those. Okay, now 20 seconds is right here. That takes us to this part of the graph, which is a flat line. So what I need from you to write is this: acceleration equals slope. That tells me that you know what the concept is, okay? And now you can write the answer. Up on the graph, you should be able to show me what the slope is. Now in this case, since the velocity is 0, the acceleration is also 0. Okay, what is the acceleration at 5 seconds? Well, so 5 seconds would be right here, which is that part of the graph. Okay, now, if we go to that part of the graph, we're basically finding the slope of that line segment. So that slope would be negative 20 over 10. So what's negative 20 over 10? That would be negative 2 meters per second squared. So the acceleration for this part, okay, again, equals slope, but what's our, we're going to write our rise and our run. So negative 20 meters per second over 10 seconds gives us negative 2 meters per second squared. So there is some work required for you to show, but it's pretty minimal work. okay? We're just showing a quick substitution into slope or area, okay? What is the acceleration at 40 seconds? Well, 40 seconds is right at this point here, which is interesting because at that point, you need to be able, like, that's not very realistic, okay? It's not realistic at that point because there's no actual slope there, okay? So cannot be determined without a slope. So you realize that that point there is the point between two slopes, this slope and that slope. So that's not very realistic to change speeds like that. So you're basically doing what? We're increasing to this speed and then decreasing to that one. It happens usually gradually over time. It doesn't usually happen so abruptly. Okay, what is the displacement between 0 and 10 seconds? So now what I'm going to try and do is I'm going to try and find the area under it. And I'll go ahead and highlight certain regions. So this is the area that I'm looking to find right there. It's a triangle. So I'm thinking the displacement is going to be the area of that triangle, which is going to be 1/2. The base is 10 seconds times the height, which is 20 meters per second. Okay, and so if I go 10 times 20, that's 200. Take half of that, we have 100 meters is our displacement for the first 10 seconds. Okay, what's our displacement between 10 and 25 seconds? Well, between 10 and 25 seconds, you didn't go anywhere. You didn't go anywhere. You're not moving. So your displacement would be 0 during that particular time interval. Now, between 25 and 30 seconds, so let's see, between 25 and 35 seconds, now what we're looking at is we're looking at this section here, 25 to 35. So let me erase a few things so we can see a little more clearly. So 25 to 35 would just be that. So there's 25 there, 35 there. It would be just that little triangle right there, okay? Now it's on the negative side, so it's going to be negative displacement, okay? So we've got delta x, oops, sorry, wrong color. Delta x equals 1/2, okay? We're going to area again, and I'm actually going to write it as negative because it's negative area, negative displacement. The base would be 10 seconds again, times the height of that triangle, which at that height it's getting to 10 as well. 10 times 10 is 100. Take half, of course, is negative 50 meters. Okay, now what is the displacement between, the total displacement between 0 and 110? Well, here's what we have to do now. What we do now is we find all the displacements and we essentially add them up, okay? So here's the way I'm going to do that. We already know what the displacement for the first, and I'm going to kind of color them out so you can see them, okay? Okay, and I'm going to get rid of this shaded region. There's no displacement there. Displacement is 0 for that section. So displacement is 0, velocity is 0, acceleration, everything is 0 right there. Okay, now when we get to this next section, it would probably be advised that you break this into triangle, rectangle, and large triangle. So you can kind of see it break down. Here's smaller triangle, here's bigger rectangle, and then here is larger triangle. So we're basically finding the area of 1, 2, 3, 4, 5 shaded regions. The total area is the total displacement. Okay, so let's do this. What is the area for this part here? We already did it. 10 times 20 is 200, take half, that would be 100 meters right here. Okay, base, well, you're going 25 to 45. So the base is 20, the height is 15. 20 times 15 is 300. Take half of that. This is negative 150 meters down here. Okay. The third shaded region has a base of 10, a height of 30. That's 300. Take half. We're looking at positive 150 for that 10-second interval. Okay. For this section here, we're looking at a base of 15 times a height of 30. 15 times 30 is 450 meters there. And then finally, the last one, we have a base of 10, 20, 30, 40, height of 30. Well, 30 times 40 is 1,200. Take half of that. That would be 600 meters. So let's add all that up. So we're going 100 meters, okay, minus the 150 because it's negative, okay, and then add everything else. Plus 150 plus 450 plus 600, okay? Okay, I hope you got that. So our total displacement would be 100 minus the 150, which is the negative displacement, plus the 150. You can see that's going to cancel right away, right? Plus the 450 plus the 600 meters. And you should get about 1,150 meters if you do it right. Okay, what is the total distance traveled by this car? Well, total distance means you disregard direction. So I'm not going to subtract anymore. I'm going to add that extra 150. So what is 1,150 plus 150 more? Let me see. It's about 1,300 meters. Okay, so now, during which time or time intervals was the car at rest? Well, the car was only at rest between this time interval here, which is 10 to 25 seconds. So let's squeeze that in where we can fit it. So between 10 and 25 seconds. During which time intervals is the car moving in reverse? That means going backwards. Well, that's the negative velocity down here. That would be from 25 to 45 seconds. From 25 to 45 seconds, we're going in the negative direction. On the graph to the right, sketch the accelerations as a function. So we're going to sketch those slopes. Okay, now I know we didn't find all the slopes, but we're going to find all of them. I'm going to kind of erase some of this other stuff here that's kind of in the way. That way we can get a clean version of what we're doing here. In fact, let me just get rid of it all. Okay, let me have a cleaner version of it. Okay, so how many slopes are we finding here? 1, 2, 3, 4, 5, 6 slopes. Okay, first slope, down 20 over 10. Okay, that would be -2. This is a slope of a horizontal line. That would be 0. This slope here looks like we're going down 15 over 15. That one's nice and easy. That one would be -1. Okay, now for this big line here, you can either do up 3 over, up 15 over 5. You could do up 30 over 10. You know, it doesn't matter how you do it, but you should get 3 meters per second squared on that one. Okay, this one right here has an acceleration of 0 again because it's a flat slope. And then finally, this lower one here, I can go down 15 over 20, or I can go down 30 over 10, 20, 30, 40, down 30 over 40. So down 30 over 40 would be negative 3/4, right? Or negative 0.75 meters per second squared. So the largest seems to be 3, the smallest seems to be negative 2 on the other side. So that's how I'm going to create my scale. Looks like I'm going, okay, we can go 1, 2, sorry about that, 3 going up, and we can go negative 1, negative 2, negative 3 going over. Use the exact same time scale that we have here. Every 2 boxes will be 10. And actually the time scale is already created here, which is nice. All right, so let's plot this. For the first 10 seconds, we're plotting negative 2. So I'm going to plot that for 10 seconds. Okay, then for the next 15 seconds, from 10 to 25, we're at 0. Just like that. Okay, then we are at negative 1 for 15 seconds. Just like that. Okay, then we're at 3 for 15 more seconds. Just like that. Okay, you can connect them if you want. You don't have to. You can leave them discontinuous. That part doesn't really matter. If you want to connect them because it's really bothering you to leave them disconnected, that's fine too. And then finally, you're back to 0 right there. So that would be right here for 15 seconds. Again, if you want to connect it, go ahead. You don't have to. And then finally, the last time until 110, okay, we're going 70 till 110 at negative 0.75. So you can see, we zoom in, this is negative 1/2, negative 0.75 would be about right there. So that would be from 70 to 110, and there, ladies and gentlemen, is our acceleration time graph. Okay, so that's part 12 here, is sketching that on this graph right here. Okay, number 13, at what times other than 0 was the displacement of the car exactly 0? Well, that happens, guys, when the displacements cancel. So if you think about it, you went from, if I remember what these were, this was 100 right here, okay? And then this, if you remember, was 20 times this is 100. This was negative 150, right? So if you think about it, you went forward. We went forward 100 meters, right? Here you went backward 150 meters. Which means sometime in here, sometime in probably about maybe right here, okay, you would have the exact same. Now I could kind of sort of figure it out if I can get what the area, if I could find the area to be exactly 100 to match this 100 forward. If I can find the area of 100 backward, that would tell me exactly what time. So if I kind of went this 3 here, let's see what that gives me. That would be 15 times 15 is 300. Take half. Wait, am I doing that right? No, I'm not. Let me try that again. Okay, so I'm going 10. So if I go 10 times 10, that would be 50. Yeah, okay, so if I went 15 seconds times 15, did I find that right? I may have found this wrong. Hold on, let me correct my mistake here real quick. So I went 20 times 15 is 300. Take half of that is 150. Good. Okay, so that would be 15 times 15 is 225. Take half of that is 112. So if I were to find the area of this, it's about 112. So my guess is that that puts it right to about almost here. I'd have to approximate it really at this point. Okay, so basically approximately, okay, that's 35 seconds, approximately at about 37, 38 seconds. Okay, that's what would be the, so right around 30, approximately about 38 seconds on that, you're gonna get a displacement of 0.